Hello all, welcome to the next topic from electrostatics. Last class we have learnt about electric dipole and what is called a dipole. Two equal and opposite charges which are separated by a small distance is called a dipole, and we have learned some term is called a dipole moment. So dipole moment means it is vector quantity and that is directed from minus q to plus q. Okay, in today's lessons we are going to learn about electric field due to a dipole along the bisector. Last class we have learned about the first heading, right? This is a second part within the dipole. What is we have learned on the first part? We have learned on the first part the electric field due to along the axial position of dipole. If you are not remembering that topic, pause the video and see that video. Okay, then come to this topic. If you are not remembering, again I am telling, if you are not remembering the previous topic, the section A under dipole, pause this video and revise your notes and what are the things we have learned. Okay, well, I will quickly refresh topics and I will go to will be here. If we have two charges minus q and plus q charges which are separated by a distance of 2L, we are going to find out the electric field intensity at this point, which is at a distance of x meters away. We have learned the formula E will be equal to K into 2P divided by x cube. This is which this is along the axial position. So this is an axial position. Okay, axial position in the sense here, as I told before, electric field intensity, the direction of electric field intensity is like this. The direction of the dipole moment is from minus q to plus q. So if I am drawing here, it's from minus q to plus q. So like this. So I can say the angle between P and E, angle between P and E will be equal to 0 because both are in parallel directions. This is what we have learned in the last class. In today's class, we are going to learn about electric field due to a dipole along the perpendicular bisector. What is called a bisector? In biology also, the Neet students are learning about bisector. Bisector means the equal parts. If you are cutting at a certain area, both left and right part or the upper or the bottom parts are equally divided. That is called bisector. Perpendicular means we are cutting it perpendicularly. So let's move to this topic. So in this case, we also have a dipole minus q and plus q, which are separated by a small distance of 2L. And here we are going to find out electric field along the perpendicular point. Say I am taking this point. Okay, so let me make this diagram little more bigger. So I will use this full area. Then it is little more clear because we have to draw many things. Okay, so minus q to plus q, this is called dipole, and the dipole moment direction is like this, and the distance between the dipole, it's the shortest distance 2L centimeter total distance. Here we are going to find out the electric field intensity. This is the P line. Okay, so P line means I am cutting these two lines. How should I am cutting? Perpendicular bisect means I am cutting perpendicular to it. Okay, I am cutting perpendicular. This is a line P, I am cutting perpendicular. Bisector means exactly at the center. Exactly at the center. So we have cut this line like this. So here we are going to find out an electric field intensity. Here also electric field intensity is due to minus q charges present here. Electric field intensity due to plus q charges present will be here. As I told, the properties of electric field lines are going away from positive charges, right? Away from positive. So with respect to this positive charge, electric field lines are going like this. So with respect to minus q charge, electric field lines are going towards the charges. So these 2 points we have marked. Now we will see what's happening. Let me complete this as a triangle. Okay, this angle is theta, so of course this angle is also theta. You can consider this as an isosceles triangle because bisector I am cutting and the two base angles are equal as per mathematics. So these are equal. Now this is the electric field due to minus q charge and this is the electric field due to plus q charge. To understand easily, I am giving E minus, I am giving E plus. Okay, for our easy understandability, I am giving E plus and E minus. Next, I told everything if you want to solve it in physics. Okay, whatever we are going to solve it in physics, we need it on x-axis, we need it on y-axis. But here this is not in x and y axis, correct? This is in between x and this plus E plus is look like this one and E minus is look like this one. So this is not in x axis, this is not in y axis. So in this case, what we will do? We will split this vectors, right? We will split it. So this is a two-dimensional quantity. This is a two-dimensional quantity. Whatever is along the x direction, whatever is along the y direction is called one-dimensional quantity. But here it's between x and y, between x and that is called two-dimensional quantity. So we need to convert this two-dimensional quantity into two one-dimensional quantities, which means this angle is theta, right? I'll draw a parallel line parallel to this P. I'm drawing line. If this angle is theta, what is this angle? This horizontal line making an angle theta with this one. So what should be this angle is also theta. Here also this line with horizontal making and theta. So what is this angle? Opposite angles are equal as per mathematics, right? This angle, this angle, this angles are equal. Okay. Now I am splitting this electric field into a two components. I told the side which is nearer to theta because of E plus is called E plus cos theta. Because of E minus, I can say E minus cos theta. So E plus cos theta is there, E minus cos theta. Both are directing towards this line. And the other side opposite to theta, which means this side, because of this one. This is called what? E plus sin theta. The area, the side which is close to theta is called E cos theta, adjacent side. Okay, and this for this E minus, I split it as E minus cos theta. So the other side is called E minus sin theta. I repeat it again. Last class also I told theta is this side. If x is an adjacent side, y is an opposite side, z is an hypotenuse, then I can write it as cos theta equal to adjacent side by hypotenuse, which means x by z. So x will be equal to z cos theta and y will be equal to same way z sin theta, which means the side very closer to x is called hypotenuse into cos theta. So this is cos theta side, this is sin theta side. Similarly, this is a side very close to theta and this is called cos theta side for E plus and this is a cos theta side for E minus. Similarly, E plus sin theta and E minus sin theta. Okay, hope it is clear for you this diagram. So let's move ahead and we'll say what all the components will get cancelled. This already many times we have learned the same stuff in electrostatics also, right? This is a plus component, this is a minus component, and which are in opposite direction, and E plus and E minus are equal in magnitude wise. Sign wise it is different, right? In magnitude wise it is equal. So E plus equal to E minus actually, because this is at a distance of from here to here at a certain distance, from here to here this is at a certain distances. So the distances from the bisector to this point, okay, electric field due to a dipole along the bisector. So from here to this bisector point, this total distance I am taking as x. Okay, exactly from the middle. Now E plus sin theta, E minus sin theta, I am saying E plus equal to E minus equal to E, both are equal. There are no differences, so both are equal. So in this case what will happen? E plus sin theta will cancels with E minus sin theta. So let's write E plus sin theta equal to E minus sin theta, as they are opposite. So what will happen? They are cancel each other. They will cancel because they are opposite direction. They will cancel each other. But what is the net electric field now? E cos theta and E sin theta, E plus and E minus. Now onwards I am saying just E. So this is along this direction. These are the same vector directing towards this direction. So we are not cancelling. This can be added because vectors are in the same direction. So I can say the total electric field E net will be equal to 2E cos theta. Okay, we are substituting for cos theta. Cos theta and E. So 2 into what is electric field? 1 by 4 pi epsilon 0 Q by R square. So 1 divided by 4 pi epsilon 0. For that factor I am giving as K. Okay. K into, because of plus Q and because of minus Q. Because of plus Q, the electric field is like this. Because of minus Q, electric field will be like this. Okay. So only the directions are different because of plus Q and minus Q, but magnitude wise it is same. So K into Q divided by, what is R square? K into Q by R square. R is a distance from here to here and here to. So this is I am giving as R. This is I am giving as R. So we have to write R square. But as per this triangle calculations, R square is an hypotenuse. I can say base square. Base square means what? L square, half of the distance, plus X square. So this I can substitute there. I am substituting L square plus X square into what we have extra, cos theta. Cos theta means what? Opposite adjacent side, L divided by hypotenuse. So L divided by hypotenuse is what? Hypotenuse is R, not R square. So R means what will come? Root of L square plus S square. So root of L square plus X square. Further simplifying, we know one term which is called dipole moment. What is dipole moment? Any one charge into distance between the charges. This is what we have learned in the last class also, right? Distance between the charges. So here Q into 2L, we can say P. So what it is coming will be there in the numerator. 2QL will goes to P. Hence the formula Kp divided by, we are combining this. This is power 1. This is power 1 by 2. 1 and 1 by 2. 1 plus 1 by 2. Which means how much will come? 3 by 2. L square plus X square divided by 3 by 2. This is the total electric field. Okay. This is the total electric field created by a dipole along the bisector. Along the perpendicular bisector. Next, the main important point is the direction of, listen very carefully, the direction of dipole moment is from minus Q to plus Q like this. What is the direction of electric field? Opposite side, which means I can say my P is in this direction and my final electric field in this direction. So here I am writing a note, an additional point, angle between P and E will be equal to 180 degree. Very important point. This is previously asked for an entrance examinations. So the angle between P and E will be equal to 180 degree when we are calculating the electric field due to a dipole along the perpendicular axis. Along the axis, our first case, section number A. In the along the axis, what is the angle between P and E? When I'm starting the class, I told angle between P and E will be equal to 0, but here it is 180. 180 means opposite to each other. Very important, note on the point. Okay. Now, next we'll say, we know 2L itself is very small. So if you're taking half L, that is very small, and L square is too small. Okay, so we will say we know X is much greater than L. In this case, if X is much greater than L, what we can eliminate and what we can add? If X is greater than L, 2L is this much size. L is this much size, again short, right? Then L square means it will tend to 0. In this case, L square tending to 0 means more closely equal to 0. So L square can be neglected here. If I am neglecting L square, what will come? If L square is not here, what will come? X square 3 by 2. 2 and 2 cancels. So what will come? X cube. So in this case, the formula K equal to Kp divided by X cube will come in this case. Okay. Next, can you compare the formula will be here. Along the axial position, K into 2P by not X square, it is X cube. Okay. K into 2P by X cube. Here, what is the formula? Kp by X cube. So, axial electric field. Here maybe I can substitute axial. Here I can substitute a perpendicular bisector. So, I can say an axial electric field is equal to 2 times of perpendicular electric field. Okay, axial electric field K into 2P by X cube, perpendicular just Kp by X cube, that is no 2 will be here. So 2 times of perpendicular electric field will be equal to what we will get it? It is nothing but axial electric field. So just add an additional point, E axial equal to 2 times E perpendicular. So E axial is equal to 2 times of E perpendicular. Okay, now hope you understand everything. Now pause the video and complete the notes, whatever you understood. Whenever you come across some doubts, look into this board. Okay, so this is important. Angle between P and E equal to 180 degree, and the formula also have to remember K into 2P by x cube and Kp divided by x cube. This you don't want to remember, but this you have to remember while solving the numericals. But this is important. Angle between P and E along the axial positions are 0. Along the perpendicular bisector, P and E are in opposite direction, which is making 180 degree. Hello all, welcome to the next topic. Okay, so here we are going to learn about electric field intensity at any point due to a dipole. Two cases, first two cases we have learned. This is our third cases. First two cases means electric field along the axis of a dipole, electric field along the bisector of a dipole, or it's a perpendicular point, that is also called equatorial point. Okay, that is also called the equatorial point. You don't want to confuse, but it's called equatorial point. Here we are going to learn about electric field at any point. Just we will recollect what we have learned in the previous sessions also. Axial electric field 2 kp by x cube, dipole moment and electric field same direction. E perpendicular or equatorial electric field or perpendicular bisector kp by x cube. So dipole moment is in this direction, electric field is in this direction. Now here we are going to find out electric field at any point. This will be very useful while you are writing the entrance examinations, because if you are not remembering these two formula, if you only remember this formula, you can answer the questions. Okay, so let's see what we are going to see heats with respect to this point. Okay, so let me take two charges, minus q and plus q. So we have a dipole like this. So we are going to find out electric field at any point. So just I am considering one point will be here. This should not be a bisector at any point. So dipole moment is like this. So from this center, this is a dipole moment, and I'm going to calculate the electric field at some point will be here, which is at a angle of theta degree. Okay, if it is an axial position, then this point will come here. Then theta equal to how much degree? 0 degree. If it is a perpendicular point, then what is the value of theta? Electric field and dipole moment are in opposite direction. Theta equal to, in this case, if it's a perpendicular point, then theta will be equal to 90 degree. If it is an equatorial, if it is an axial point, then theta will be equal to, in this case, the axial point theta will be equal to 0. If it's a perpendicular point or equatorial point, the theta will be equal to 90 degree. So here we are going to find out the electric field intensity. Before we are going will be here, we have to see what we can do will be here. Next, listen to the board very carefully. This is called a dipole moment. Okay, dipole moment along this direction is called along the side of theta. We already learned, we call this as P cos theta. And the component which is perpendicular to P cos theta. So like this, a component which is perpendicular to P cos theta. So this P cos theta and this line, this is called P sin theta. We are going to find out electric field along these lines. Okay, listen very carefully. While we are writing E axial, the dipole moment is passing through the same point of electric field intensity. Then we are writing 2 kp by x cube. Here P is passing through the same point, and in this case P cos theta is passing through the same point. Okay, so here I have an axial component is there. What is that axial component? Can you tell me what is that axial component in this case? This P cos theta is passing through that line. So the same formula 2k, but instead of P, what here P is passing, but what is passing here? P cos theta. So P cos theta divided by x cube. I'm assuming this distance is x meter away. So based on that assumption, it is 2 kp by x cube. Okay, so the electric field along the axial in the same line, this is called axial electric field. For this line, this P sin theta line is perpendicular. This P sin theta line is perpendicular to P axial line. So this P is perpendicular to electric field. In that case, along this line, E axial is giving 2 kp cos theta by x cube. But for this line, this is perpendicular. So there is a perpendicular electric field will be there. What is the value of this one? 2. There is no 2. What is the perpendicular formula? Kp by x cube. Here P is like this, and this is a perpendicular point. So here P sine theta is like this, and this is a perpendicular point. So for this point, what is P will come? Kp sine theta divided by x cube. So as I told, this electric field is opposite to the direction of electric field, and dipole is opposite direction. So this is one axial electric field along this direction, sir. And here we also need, this is a P, and for this P sine theta, this is opposite. So I have an electric field like this one, and this is called perpendicular electric field. Okay, I'll repeat again. This component we know it is called P sine theta. This component we call P cos theta. The electric field along the axis of P cos theta, it is called 2 Kp cos theta by x cube. Here P is along the axis, so we have written 2 Kp by x cube. Here P cos theta is along the axis, so what we have written? 2 Kp cos theta by x cube. Next one, perpendicular. Here this is the perpendicular point from here, and P is like this, so we have written Kp x cube. Here this is the line, and this is the perpendicular one. So what is the perpendicular formula? Kp by x cube. Here instead of P, what will come? P sine theta, because this is a line and this is perpendicular. So Kp sine theta by x cube. Now we have to mark the direction of axial and perpendicular. Axial electric field is along the direction of P cos theta. Perpendicular direction is opposite to P sine theta. Here opposite to P, right? This is the P direction, and we are marking opposite to that. So this is the P sine theta direction. So we are marking E perpendicular opposite to that. Okay. So now we got two stuff, axial electric field and perpendicular. Both are making 90 degree. How we will find the equivalent of, or the resultant of two vectors? How we will find the resultant of two vector? Resultant of two vector in between these two, and this is called E. Now we are going to calculate E. If we have two vectors A and B, so how we will find the resultant? Resultant equal to root of A square plus B square plus 2AB cos theta. We will find this formula, right? In the same way, what we are going to do means, here we are going to find out electric field. Electric field will be equal to, tell me, E axial square plus E perpendicular square plus 2 into E axial and E perpendicular into cos of, what is the angle between these two? I told both are perpendicular, so it is cos 90. What is the value of cos 90? 0. So only we have first two terms will be here. So this term is completely going to 0. What is E axial square? Is in the square. So root of E axial square. E axial square means 2 Kp cos theta by x cube. So we can write it as 2 Kp cos theta divided by x cube whole square plus. We need the perpendicular electric field also, right? So Kp sine theta divided by x cube. This is also whole square. Common terms, we can take it out of this integrations, out of this root. K square. Okay, that will come outside. So if it is come outside means it is nothing but K. P square, common I did, it is coming outside. So Kp. Okay. X cube square. So both will come Kp by x cube. So what is there in the numerator? Here it is 4 cos square theta plus sine square theta. This is the final formula of electric field intensity. Now if you want to calculate this axial electric field, E axial, in this case what is the angle between P and A? P and B angle. So E axial, P and B, angle theta equal to 0 degree. In that case, if you are substituting 0, what you will get? Sine 0, 0, cos 0 is 1. So cos square 0. So cos square means 1 square. 1 square means 1. So you will get it as 2 Kp by x cube if you substitute theta equal to 0. In case of a perpendicular bisector, this case, perpendicular bisector means this theta is pakka equal to 90 degree, theta is equal to the angle between P and E, theta equal to 90 degree. If you substitute 90 will be here, cos 90 0, so this term will go out. Sin 90 is 1, so sin square 90 means sin 90 is 1, so sin square 90 means 1 square, so it is 1. So what we'll get? We'll get Kp divided by x cube. Kp divided by x cube. So we can find the formula of axial electric field, we can find the formula of perpendicular electric field based on this is a generic formula. So this is electric field intensity at any point due to a dipole. So we are going to find out electric field intensity at any point due to a dipole. One more important point will be here. Sometimes in entrance examinations, the questions will ask electric field intensity. Suppose I am going to find out at an angle of 45 degree. Here theta equal to 45 degree. So how you will find the electric field intensity? You know this formula. You will substitute theta equal to 45 degree. Cos 45 is 1 by root 2. So cos square 45 is 1 by root 2 whole square, which means 1 by 2. Here also sin 45. Sin 45 means 1 by root 2. So sin square 45 means 1 by root 2 the whole square. So you will do it accordingly. Okay, so you will get the electric field intensity. But in an examination, they will additionally ask what is the angle between when theta equal to 45 degree. Just an example I am telling. When theta equal to 45 degree, what is the angle between electric field and theta? To find out like this, we already know theta. Okay, so now you can assume P is like this. This is our P line, and electric field line should not be exactly a 90 degree line, but okay, I will put it like this, slightly tilted like this. Okay, it should not be exactly 90 degree. So for this one angle will be here alpha. Okay, this alpha value we don't know. Suppose if you want to calculate this alpha, so I am putting this line exactly will be here. So I will get something like this one. Okay, so the total angle from here to here, it's called up to this line, it is theta, then extra alpha. So I can say theta plus alpha is the angle between electric field intensity and P. So how to find alpha? Theta is already given in the question, 45 degree. How to find alpha? Alpha is quite simple. How we can find out alpha? Let me write tan alpha. What is tan alpha? Opposite side by adjacent side. What is opposite side in this case? Opposite side means perpendicular electric field. What is a perpendicular electric field? Here we have a perpendicular electric field is our second term. Axial electric field is our first term. So perpendicular means second term. What is the second term? Kp sin theta divided by x cube. This is x cube. Okay. Whole divided by perpendicular by axial. Axial means what? 2 kp cos theta divided by x cube. Okay. So kp by x cube, both numerator and denominator cancels. Sin theta by cos theta, tan theta, 1 by 2. So what this formula will come? It is called 1 by 2 tan theta. So this formula will becomes as 1 by 2 tan theta. So 1 by tan alpha equal to 1 by 2 tan theta. Theta value already we know 45 degree. Okay, so in our examples I told we'll write angle between P and E in this case equal to theta plus alpha. Alpha value I want to find out. What is alpha value? 1 by 2 tan theta. So theta is 45 degree. So I can say the total angle is theta plus 1 by 2 tan theta. This is also very important to learn. Okay. So this is all about dipole sessions. Dipole 3 cases we have learned. The 3 cases we have 6 points totally. Remember like that. We have totally 3 cases and we have 6 points. Electric field intensity along the axis of a dipole. Formula is 2 kp by x cube. Angle between P and E will be equal to 0 degree. Point number 2 points in one heading. Second point, electric field intensity along the perpendicular bisector. So the formula is kp by x cube. Angle between electric field and dipole moment is 180 degree. P P and E angle is 180 degree. Third case, this one, electric field intensity at any point due to a dipole. Formula is Kp by x cube into root of 4 cos square theta plus sin square theta. Theta equal to 0 degree for an axial position and theta equal to 90 degree for an equatorial or perpendicular bisector positions. Now, in this case, what is the angle between P and E? Final E. P and E angle is theta plus extra alpha. So, theta plus alpha means theta plus 1 by 2 tan theta. These are important. So, totally 6 core points are there. Okay, magnitude, we have totally 3 headings. So, each 3 headings will consist of 3 formulas. And in additional to the formula, we are specifying the angle between P and E. P and E are in same direction axial position. P and E are in opposite direction. One is going like this, another is going like this. In case of an equatorial positions or in perpendicular bisector position, and in case of at any point, the general formula is theta plus 1 by 2 into tan theta. Okay, this is the main points what we are going to discuss in this 3 areas. Okay, remember these 3 areas, it's quite important. There are a lot of questions are already came from this area, so you can also expect some more questions, some more tricky kind of questions also from this area. So understand the concepts. Okay, thank you.